When we look at solving linear inequalities, all of the rules that we used for solving linear equations carry forward with us. Meaning to solve an inequality like 3x is less than 6, we need to isolate x on one side of the equation by itself. To do that, we'll multiply both sides by the reciprocal of that coefficient in front of x. On the left-hand side, 1/3 times 3 will reduce to just 1, leaving us with x is less than 6 times 1/3, or 6 divided by 3, which is going to be 2. We can express that solution simply by leaving this as x is less than 2. We could graph that solution on a number line, or what we were asked to do in this problem is to translate that solution into interval notation, which in this case would be -∞, comma 2, with rounded parentheses on both ends, since we have that strict inequality. In example 7, we introduce a new rule that applies when we're solving inequalities that didn't apply when we were solving equations. We start off similarly here. We'll multiply both sides by the reciprocal of that coefficient, meaning we'll multiply both sides by -1/4, which will give us x and 0. But since we multiplied or divided both sides by a negative, the other thing that we have to do is flip the direction of that inequality symbol. Instead of greater than or equal to, now we have less than or equal to. Off to the side, we can quickly demonstrate why we need to flip the direction of that inequality. If we started off with, for instance, something like -3 is less than 2, and then multiplied or divided both sides by -1, we would get +3 and -2. If we kept a less than symbol, that statement would be false. So what we have to do is flip the direction of that inequality statement in order to maintain the truth of the original statement. So if we multiply or divide both sides of an inequality by a negative number, then we need to flip the direction of that inequality symbol, and we can represent, in this case, our interval solution as -∞ to 0 with a closed bracket at 0. In example 8, we have a little bit more work to do, but our rules from solving equations, again, carry forward with us. So we'll first group all of the x terms on one side of the equation, giving us 6x is less than or equal to 24. And then we'll multiply both sides by the reciprocal of that coefficient, which will give us x is less than or equal to 24 divided by 6, or x is less than or equal to 4. Expressed as an interval, that would be -∞ to 4, again with a closed bracket here since we have that or equal to statement. In example 9, we want to start by grouping all of our variable terms on one side and constant terms on the other side. The first thing we can do, though, is get rid of those parentheses. Since there's nothing to distribute through, this is just the same thing as -2x plus x plus 8 is less than 8x plus 2. We'll subtract 8x from both sides. No, actually, before we get into doing that, we'll simplify what we have. Combining like terms on the left-hand side will give us -1x, or just -x, plus 8 is less than 8x plus 2. Once we've combined like terms, now we can start moving pieces from one side of the equation to the other. So we'll subtract 8x from both sides, and we'll also subtract 8 from both sides. That will leave us on the left-hand side with -9x. Is less than -6. Then we'll multiply both sides by the reciprocal of that coefficient, which in this case will be -1/9. leaving us with x is less than or equal to positive 6 over positive 9, as those two negatives will cancel, which will come out to be approximately 0.6667. So our solution would be x is less than or equal to 0.6667 if we round that off, leaving us with the interval. Actually, if we stop right there, I need to jump back because I missed a step. We multiplied both sides by -1/9. So when we do that, we actually need to change this. For some reason I put an or equal to in there as well. Since we multiplied both sides by -1/9, we need to change the direction of that inequality. We shouldn't have introduced that or equal to portion. So we have x is greater than 0.6667, leaving us with the interval 0.6667 to infinity with rounded parentheses on both ends. Looking at one more example, the first thing we need to do is take that -10 and distribute it through that set of parentheses, giving us 3x minus 10x minus 50 is greater than or equal to x plus 3. Combining like terms on the left-hand side will give us -7x minus 50 is greater than or equal to x plus 3. Now we can subtract x from both sides and add 50 to both sides, leaving us with -8x is greater than or equal to 53. Our last step will be to multiply both sides by -1/8. Since we did that, we have to change the direction of that inequality statement, giving us x is less than or equal to 53 times -1/8, or x is less than or equal to approximately -6.625, which would translate into the interval -infinity to -6.625 with that square bracket, since we have that or equal to statement.